Hi there everyone, in this video we're going to be looking at non-uniform continuous probability distributions. So in the last video the distributions were just flat and we worked out probabilities and everything associated with them. So these ones here are going to be a little bit funkier than the other ones, and non-uniform, so that's what this means by non-uniform. So if you look at the first one here, you can see that we've got a triangular shaped distribution, and the first question here is find the value of k. Okay, so we know that the area underneath the distribution, and here it's defined between 5 and 1, we know that area that I've shaded must be 1 for it to be a probability density function. So a half times the base, so that's 4 along the base, times k is equal to 1. So we get 2k is 1, so here k is equal to a half, or 0.5. So that's how you do part A. Part B, what is the probability that x is greater than or equal to 3? So if I go back to the diagram here, that is that shaded area there. Remember, area under the curve is the same as probability here. Well, there's heaps of ways of doing this question. I think the easiest way is to work out this area here and subtract that number from 1, because we know the whole area is going to be equal to 1. So I'm going to do that. Bit of similar triangles here, because in working out that area, it's a triangle, the base is 2, the height is that right there. Well, let's look at these similar triangles. That triangle there is similar to this triangle here. So if we know that 3 is halfway along the base of the triangle there, then we know that the ratio of these heights is also going to be half. So if we know that that is a half, we know that that length right there is going to be a quarter, or 0.25. Okay, so that's a little bit of similar triangles there will help you to see what that height is. And similarly, if we moved it so it was 3/4 the way along, then this height here would be 3/4 of the total full height there. Okay, similar triangles. Okay, so therefore, let's get this. So that is going to be a half times 2 is 1, so that is 0.25. Okay, so that's that blue area there. Therefore, we can say that the shaded green area that I had before is 1 minus 0.25, or 0.75. Now, here's another way that you could think of it. You could do it, say, work out the area of that trapezium shape directly. So if I look at this shape here, that is a trapezium, and the area of a trapezium is a plus b over 2 times h, where a and b are the lengths of the parallel sides. So in this case, the lengths are 0.5 and 0.25, and the height in this case is the distance between the parallel sides, and that is 2. So that also will give us 0.75. Or you could just do the integration if you wanted to. So if you worked out the equation of this function here, which isn't too hard to work out, then you could do the integral there. What is the equation of that function? So we would say that the gradient is rise over run. So we've gone up a half and across 4. A half divided by 4 is 1/8. And if we took this back, because the gradient is 1/8, that's going to be negative 1/8 on the y-axis, isn't it? So you could say that the equation here is, I'll write it out in full, 1/8 x minus 1/8, and that's defined between 1 and 5, and we say 0 otherwise. So it just covers us so that we're absolutely sure that everywhere else the function's equal to 0. So we could just do the integral of that function between 5 and 3, and we would also get the answer. And there's another way here as well I can see. This is super tricky. If we split this area up into 3 triangles, we now have 3 congruent triangles. They're all the same. And the area of this one down here is a half base times the height. And again, this height here is half of a half, or a quarter. 0.25. So that area there, that shaded one, is 0.25, and we've got 3 of them, so 0.75. So there's lots of ways of doing this. I would avoid the integral one if you can. If you can work out areas of triangles, way easier. So is this a probability density function? So this is in the calculator section. Let me show you the moves that you'd make on your CAS calculator to check this one. Draw it in the interval -2 to 2. So if you drew that, you can see that between -2 and 2 the curve is above the x-axis, so all the values are positive. That's one of the characteristics of a probability density function, so we're good there. And then in main, you could check that the integral, or the area underneath the curve, between 2 and -2 is 1, which it is. So that's how you could use your CAS in this question here to verify if a function is actually a probability density function. In this question here, again, it's a non-uniform probability density function. So I reckon drawing it is really the best way to go here. So 4 minus 2x, so it's got a y-intercept of 4, a gradient of -2. So this is going to be 2 here, that's going to be 4 there. And this function is only defined between 1 and 2. Okay, so really it's only that part there. So if I get rid of everything else, it's just that little part there. And we can pretty quickly see if we go across there, if I substitute 1 into this formula up here, we get 2. So a half base times half 1 times 2 is equal to 1. So yes, the area under that curve is 1. So this is a PDF. And we want to know the probability x is less than 1.5. Okay. So you can pretty clearly see that our answer here is going to be greater than a half, isn't it? Because of the shape of the distribution, the answer here is going to be, yeah, much bigger than a half there. So again, I reckon same way of doing this, better than doing the integration, although you could, is to work out the areas of the triangles. So I'd work out the area of this little one in here. Again, by the same reason as the last one, the height here is half of this height here, because of similar triangles there. Okay, so the height of that big one is 2, so this height here is 1. So the area of this triangle is a half, the base is 0.5, that length along there, and the height is 1. So that gives us a quarter, or 0.25. So we can see therefore the shaded area, the total area is 1, so therefore the shaded area that we're looking for is 0.75. And that's the answer to that one. Again, try and use the triangle idea rather than going for the integration idea. Even though the integration will work fine, the probability is the integral from 1.5 to 1 of 4 minus 2x dx. Okay, that's the probability x is less than 1.5. It's good to know both ways, you know, and I think both ways are valid and both ways are okay, but I think it's quicker, you know, from there. I mean, you can do that on your calculator, sure, but from there it's a little bit longer, a little bit more tedious, so go for the triangle way if you can. So this one's a little bit different. We want to find the value of k here. So we know that the area under the curve here has got to be 1. So the integral from 2 to 0 of kx squared with respect to x is equal to 1. Okay, so if I put the k out the front and do the integral, I get x cubed over 3 between 2 and 0, and that is equal to 1. So substituting 2 in, 2 cubed over 3, so that's 8 over 3 minus 0 over 3. So 8 over 3, k, is equal to 1. So times by 3 divided by 8 gives me k is equal to 3/8 in that one there. This is a really interesting continuous random variable because we use this random variable to describe things, the interval between two events happening, and any random variable in this form here we use like that. So the 0.5 might change, but anything in the form ke to the negative kx is a random variable that we use for this, the time between successive occurrences of something. So what's the chance that x is less than 2? So if we look on this function here, we've got 2 we want the area under the curve between 2 and 0. So I've just done the same thing. I've done the integral. In this case, I'm using 0.5 instead of k. And we get down to this step here, which is the same one that we had before. I substitute in 2 and I substitute in 0. I do that really carefully at this step here. Don't assume, because a lot of people get tripped up here. E to the power of 0 is 1. So that's a tricky one. Sometimes people don't get. So I could write that as negative 1 over e plus 1, or 1 minus 1 over e, or the decimal equivalent, which is 0.6321. So it's just the area under the curve. Nothing special, just applying integration to continuous random variables now. Part B is really similar. We just go the integral from 10 to 5, but I want to do part C. The value of d for which probability x is less than or equal to d is 0.5. This is actually the definition of the median of a continuous random variable. The value on the axis there, so that half of the area is one side and half is on the other side. Okay, so from the answer from part A, we can see that the area from 2 down was 0.63. So obviously, the answer to this question's got to be inside that. So we're looking for a value of d here, so that that shaded area there is exactly 0.5. And you could say also that the area above there is also 0.5, because the total area is 1. So here's the working for that. The integral between d and 0 of the function is equal to 0.5. So we do the integration again. Okay, that gives you this step here. Got to be really careful. So it's 0.5 out the front, negative 1 over 0.5 e to the negative 0.5x leads you to that. Substitute in d and substitute in 0. And we know that this one here is going to be equal to 1. So we get plus 1 there. Okay, subtract 1 from both sides, gives us that step there. Then I've done negative to both sides, so I've just times both sides by negative 1 here. And now I can do ln of both sides. Only when I get e to the power of something, that's when I do ln. Don't go any earlier. Leave it to the last second. So I've done that. Ln of this side here is obviously equal to just that, because ln and e are inverse functions. Divide by negative 0.5, and that gives me negative 2 ln a half, or ln 0.5. And ln a half is ln 2 to the minus 1. So I've just kind of simplified this, put the negative 1 down the front, 2 ln 2. So it's a little bit tricky going from there to there, but it's something that sometimes the answers say that, and people say, why have I got negative 2 ln a half? Well, it's the same as 2 ln 2. And on my calculator, that is 1.386, which from my diagram looks like it's less than 2, so it looks like it's good to me.